Hi, Assalamualaikum. To my miss and classmates, I will be introduced about fundamental of logics. But before we begin, I would like to introduce myself. My name is Muhammad Afnish bin Muhammad Afif. Okay, let's move on. So first of all, the basic principle that help us reason clearly and make sound arguments. Logic is the foundation of critical thinking and is widely used in fields such as mathematics, computer science, and philosophy. In this presentation, we will look at the key concepts such as propositions, logical connectives, and truth tables with different types of logic, including propositional and predicate logic. Understanding these basics will help us analyze arguments more effectively. So now, let's move on to the next part, which is the types of law. We begin with the identity laws. These state that when you combine any statement with a logical true or false, it stays the same. For example, P and T will get P, and P or F will get P. These laws reflect the idea that true and falsehood don't change a statement when applied in this way. Next, we're going to the domination laws. Domination laws deals with extremes. If you take any statement and say P and F, the result is always F. And if you take the statement P or T, it will always be T. This shows how dominant truth and falsehood are in OR and AND operations. Now let's move on to the number 3, which is idempotent laws. Idempotent laws remind us that repeating the same idea doesn't change. Its meaning, P and P is always P, and P or P is still P. It's about recognizing redundancy and simplifying the expressions. Next, double negation law. This one's simple but important. If you negate something twice, you end up back where you started. For example, not open bracket, not P, and close bracket, will get P. It shows how a negation cancels itself out when applied twice. Okay, let's move on to the number 5, which is commutative laws. Commutative laws say the order of statement doesn't matter for AND or OR. So, for example, P and Q will get Q and P. And other one is P or Q will get Q or P. The logic remains the same even if we swap the order. Now let's move on to the next law, which is associative laws. Associative laws, similar to arithmetic, associative laws tell us that the grouping of terms doesn't affect the outcome. For example, P and open bracket Q and R close bracket will get open bracket P and Q close bracket and R. Same goes to the P or open bracket Q or R close bracket will get open bracket P or Q close bracket or R. It's useful for simplifying the expressions with multiple terms. Okay, next is distributive laws. Distributive laws show us how to break down or factor expressions. For instance, P and open bracket Q or R close bracket will get open bracket P and Q close bracket or open bracket P and R close bracket. Same goes to P or open bracket Q and R close bracket will get open bracket P or Q close bracket and open bracket P or R or close bracket. This is very helpful in logical proofs and circuit design. So now let's move on to the next one, which is De Morgan's law. De Morgan's law are extremely powerful in logic. They show how negation affects AND or OR. If we negate whole statement like negation open bracket P and Q close bracket, we'll get negation P or negation Q. Same goes to the negation open bracket P or Q close bracket, we'll get negation P, and negation Q. These are often used in simplifying logical expressions and in programming conditions. Next one is absorption laws. Absorption laws show that some parts of an expression can be simplified or absorbed. For example, P and open bracket Q or R close bracket will get P, or P or open bracket Q and R close bracket will get P. It simplifies and helps us to eliminate unnecessary repetition in logical statements. Next one is conditional identity. Now, for conditionals, statement like if A then B, the conditional identity tells us that P implies Q will get not P or Q. This helps translate between conditionals and basic logical operators. Next is contrapositive. Contrapositive is a very useful transformation in proof. It says if P implies Q is logically equivalent to not Q or not P. The structure changed, but the truth remains the same. The last one in types of law, which is inverse. Lastly, we have the inverse. If P and not P will get F, or P or not P will get T. Unlike the contrapositive, this form is not logically equivalent to the original. It is common mistake to assume they are, so it's important to distinguish in the two. Thank you. So, to conclude, these laws provide the rules we use to build and break down logical statements, whether we're simplifying expressions, analyzing arguments, or programming computers. Understanding these laws strengthens our ability to reason clearly and correctly. Thank you for your attention.
Hi, my name is Muhammad Danish Daniel bin Azwan Shah. So, we will move to example 1. Based on this question, by using the laws of logic, simplify the following proposition and state the reasons. We move to the problem solutions. First thing first, we use the Morgan's law so that we will get open bracket, not P or Q, close bracket, or not open bracket, not Q, and R, close bracket, or not P. Secondly, we use double negations plus De Morgan's so that we will get open bracket, P and not Q, or close bracket, or open bracket, Q, or not R, close bracket, or not P. Then, we use associative law so that we will get open bracket P and open bracket not Q or Q, close bracket, or not R, close bracket, or not P. Next, we use inverse law to get open bracket P and T, close bracket, or not R, close bracket, or not P. Then, we move to identity laws so that we will get open bracket P or not R, close bracket, or not P. Then, we use associative law to get open bracket P or not P, close bracket, or not R. Next, we use inverse law to get T or not R. And lastly, we use dominations law to get T.
Hello, I'm Malik, and now we are moving on to example 2. It is given that the question is by using the laws of logic, simplify the following proposition and state the reasons. Here the question has given is open bracket P implies to Q, close bracket, and open bracket not Q, and open inner bracket R or not Q, close inner bracket, close bracket, then it will give you the answer of not open bracket P or Q close bracket. As you can see in this question, the answer has been given. So in this case, we need to solve it by doing the workflow and also state the laws of logic that we use in this question. Without further ado, let's solve this question. First and foremost, for the first row, we need to use conditional identity law because P implies to Q is equivalent to not P or Q. So the expression will be open bracket not P or Q, close bracket, and open bracket not Q, and open inner bracket R or not Q, close inner bracket, close bracket. Next, we will be using the absorption law. Thus, the open bracket not Q and open inner bracket R or not Q, close inner bracket, close bracket will turn into not Q. So the expression will be open bracket not P or Q, close bracket, and not Q. Thirdly, we need to use the distributive law. With that, we need to expand the expression so it will become open bracket not P and Q, close bracket, or open bracket Q and not Q, close bracket. After that, we need to use inverse law because Q or not Q is always false. Then the expression will become open bracket not P and not Q, close bracket, or false. Then we will imply the identity law because by adding false to any statement using or does not change in its value. So the expression will be open bracket not P and not Q, close bracket. Lastly, we will be using the De Morgan's law, and you will get not open bracket P or Q, close bracket. That's the end of the explanation for example 2.
Hello, my name is Mujahid Alauddin Muhammad Zulkifli. I want to talk about example number 3. It is the question is in the bracket not P and in the bracket P or Q. In the bracket implies Q. So it says using law of logics, simplify the following proposition and state the reason. So we move to the problem solution. First is conditional identity, and the second is the double negation plus De Morgan's law, and the third is De Morgan's law. We use the De Morgan's law double, and fourth we use a distributive law to separate the P and not Q, not P and not Q. Fifth we use a inverse law, and next is we use identity law, and after that we use the associative law, and then inverse law, and then dominations law.
So now we're going to the last part, which is the conclusion. The fundamentals of logic give us the tools to think clearly, evaluate arguments, and solve problems systematically. By understanding key concepts like propositions, logical connective, and the structure of arguments, we build a strong foundation for reasoning in many fields. Whether in everyday decision making or complex academic work, logic helps us draw valid conclusions and avoid errors in thinking. Thank you.